Can you believe it? Picture a cosmic event so huge that it casts shadows on Earth even in daylight. That's what might happen soon. Betelgeuse, a star in the Orion constellation, is acting strangely, suggesting it might explode into a supernova, lighting up our sky like never before. But when will it happen, and what will it look like, according to scientists? And what secrets might this event reveal? Let's dive deep into what's really going on with Betelgeuse and how it might affect Earth and the whole solar system. Betelgeuse, around 650 light-years away in Orion, isn't just any star, it's a red supergiant, incredibly bright, over 100,000 times brighter than our Sun. But why does it matter? Well, Betelgeuse is special not only for its brightness but also for its role in human culture. Named after the Arabic Yad al-Jawza, meaning the hand of Orion, it's been observed for centuries, guiding travelers and captivating stargazers with its reddish glow. Imagine a star so massive it could engulf our solar system. Betelgeuse, at 10 million years old, is much younger than our Sun, but its immense size means it burns through its fuel faster, leading to a shorter life. Now, nearing the end of its life, Betelgeuse is on the brink of a spectacular finale, a supernova explosion releasing unimaginable energy and brilliance. The last time Earth saw such an event was in 1604 with Kepler's supernova, visible even during daylight for weeks. Supernovae like Betelgeuse's are rare, but their remnants offer valuable insights into the life cycles of massive stars. Betelgeuse's recent behavior has astronomers buzzing. Between October 2019 and early 2023, it underwent significant dimming, catching the attention of astronomers worldwide. Although it seemed to return to normal by April 2023, subsequent months saw its brightness surge by 50%, sparking discussions about its future. Could we be on the cusp of witnessing one of the universe's most dramatic events? Betelgeuse's unpredictable behavior suggests we might be closer than we think to experiencing explosion. Stay tuned as scientists continue to monitor Betelgeuse, unraveling the mysteries of our cosmic neighborhood. But why the sudden change in brightness? Why did Betelgeuse, one of the most recognized stars in our night sky, suddenly throw a celestial curveball? Stars are not just twinkling dots in our night sky, they are dynamic entities with life cycles, activities, and mysteries of their own. For many celestial bodies, periodic brightness variations can be predicted, much like the rhythms of Earth's seasons. In its stellar lifetime, Betelgeuse is clocked in a fairly consistent 400-day luminosity cycle, but with the great dimming, it seemed to rebel against its known nature, challenging our understanding of the celestial wonders above. Now, you might be wondering, are we on the brink of a stellar revelation? While the exact reasons for Betelgeuse's irregularities are still under investigation, a compelling theory has emerged. This theory, centering around stellar activity and mass ejection, proposes a tantalizing scenario. Imagine Betelgeuse as a giant celestial volcano, suddenly erupting and spewing a colossal amount of its matter into space. In the past, observations from the Hubble Space Telescope unveiled that Betelgeuse has previously ejected an enormous amount of its surface material into the cosmos. This ejection, a colossal event, was 400 billion times the mass typically released during similar solar phenomena, equivalent to several times the mass of our Moon. Such events can lead to the formation of a dense dust cloud around the star, affecting its apparent brightness and making it temporarily harder to observe. Then, once this dust began to disperse or was pushed away by the force of the star's radiation pressure, the veil lifted. This could explain its subsequent return to regular brightness levels. Either way, these recent events hint at a star that's not done with its surprises. Many speculate that Betelgeuse might be approaching the twilight of its life, a supernova event. A supernova is a cataclysmic explosion, an astounding burst of energy that can outshine an entire galaxy momentarily. This phenomenon occurs when there is a sudden change in the star's core. Such changes can arise if a star absorbs too much matter from a neighboring star, or in Betelgeuse's case, from the exhaustion of its nuclear fuel, which cascades its mass into the core, setting the stage for a cataclysmic collapse. But what drives a massive star like Betelgeuse to its demise? Born from the gravitational collapse of gas within molecular clouds, stars like Betelgeuse kickstart their journey by burning hydrogen in their cores. This initial phase, known as the main sequence stage, lasts for millions of years and forms the backbone of a star's life. But as stars run low on hydrogen, they evolve, embracing new energy sources. In the case of Betelgeuse, as the hydrogen depletes, it begins to burn helium, leading to the formation of carbon and oxygen. This transition from the main sequence phase to the helium-burning phase is marked by the star's expansion into a red giant. With time, as helium reserves diminish, the star undergoes further expansion and shifts into other burning phases, each characterized by the fusion of progressively heavier elements. The bigger the star, the quicker these transitions, given the immense gravitational pressures at play. Then comes the climax, when iron starts forming at the core. Unlike lighter elements, iron doesn't release energy when fused, so the energy produced isn't enough to resist the star's own crushing gravity. The star balloons in size and creates an implosion, followed by a massive rebound effect, resulting in the explosive force of a supernova. So, is Betelgeuse on the brink of an explosive end, or just biding its time? Recent research by Japan's Tohoku University suggests that the star might be in its carbon-burning phase right now. Lead researcher Dr. Hideyuki Sayo believes that the core might collapse a few decades after its carbon reserves dry up, but not all scientists agree. Contrasting studies from Hungary's Konkoly Observatory speculate that Betelgeuse is still in the earlier helium-burning stage. The one thing that scientists do agree on, regardless of these debates, is that Betelgeuse is slated to become the Milky Way's next supernova. Yet pinning down the timing of this event remains a cosmic guessing game, with bets ranging from mere decades to 100,000 years. Amidst these scientific debates and speculations about Betelgeuse's fate, one fact remains unchallenged: the very nature of our observation. When we look up at the starry expanse, there's a subtle paradox we often overlook. This paradox is rooted in the very nature of time and light in our vast cosmos. Stars and celestial bodies are so distant that their light takes a momentous amount of time to reach our eyes. For instance, the speed of light. While being an astounding 186,282 miles per second, still has its constraints. Consequently, the light from remote stars and galaxies takes its sweet time to traverse the vastness of space before it graces our sight. Gazing at Betelgeuse, you're actually witnessing a spectacle from 650 years in the past. To put that in perspective, when this very light embarked on its journey toward Earth, the Renaissance was just dawning, and explorers like Marco Polo were making their mark in history. Every observation we make of Betelgeuse is like looking through a cosmic time capsule, granting us insights into its distant past. And if, for argument's sake, Betelgeuse had already exploded in a magnificent supernova, we'd remain oblivious for another 650 years. So while we discuss and predict its impending supernova, somewhere out in the vast cosmos, this monumental event might have already unfolded. We're just waiting for it to traverse space and time until it reaches our eager telescopes. The recent revelations around Betelgeuse have led to fervent discussions in the astronomical community, with comparisons being drawn to another sensational discovery from earlier this year, SN 2023X. This recently observed supernova, occurring in a galaxy neighboring the Milky Way, reminded many of the fascinating dynamics and unpredictable nature of the universe. SN 2023X was unique in its own right. Located several million light-years away, it showcased an intense display of brilliance that momentarily outshone its host galaxy. But what made it particularly interesting to scientists and casual observers alike was its uncanny resemblance to what many predict will be the fate of Betelgeuse. The spectrum, intensity, and aftermath of the explosion offered a tantalizing glimpse into the processes that these massive stars undergo as they approach the end of their life cycles. For many, SN 2023X served as a preview. If and when Betelgeuse meets its explosive fate, the sequence of events may look similar to what was witnessed with SN 2023X. In addition, the connection between these two celestial events underscores a broader theme about the interconnectedness of our universe. Whether it's a neighboring star like Betelgeuse or a distant supernova such as SN 2023X, these cosmic phenomena remind us of the dynamic and evolving nature of space. The realm of space exploration is full of uncharted territories and unsolved mysteries, and nowhere is this more evident than in our understanding of red supergiants like Betelgeuse. As brilliant as they are enigmatic, these celestial giants hide some of the universe's most profound secrets. At a fundamental level, the life cycle of red supergiants, though charted, is punctuated with ambiguities. While we know that these stars evolve from the main sequence phase to their grand supergiant stature, the intermediary processes are less understood. Often, these phases, which might involve tumultuous upheavals in the star's core, are still subjects of intense research and debate. Second, red supergiants are known for shedding massive amounts of material in their later stages. This process is crucial in shaping their evolution and eventual supernova explosions. Yet, how they lose this mass, at what rate, and what triggers these outbursts remains unclear. Betelgeuse, with its recent fluctuations, only adds to this prevailing uncertainty. So, what are the implications of a Betelgeuse supernova? At the heart of this cosmic drama, an event of stellar proportions is set to occur. Dr. Stan McMullen from Western University suggests that when Betelgeuse does finally explode, it will momentarily be one of the brightest objects in our sky, outshining all other stars and possibly even some planets. For context, even at its vast distance of 650 light-years, the luminosity could rival or even surpass that of the Moon. Night would turn into a pseudo-day for weeks or possibly months. This blinding display would last for weeks, forever changing our perception of the constellation Orion. The following months would see this luminosity fade, and after decades, an outer shell of the once vibrant star would present itself as a planetary nebula surrounding the dim remnants of its core. Astronomers and astrophysicists worldwide are evaluating the potential effects of such a spectacle on Earth. There's some speculation that an explosion could release cosmic rays, high-energy particles that travel through space at nearly the speed of light. These particles would race across space, potentially colliding with interstellar material and ionizing it, leaving a trail of charged particles. When these cosmic rays approach Earth, they could interact with our magnetosphere, producing some gorgeous auroras. But does this mean we're likely to face some serious consequences here on Earth? Thankfully. Betelgeuse is far enough that these rays would likely be diluted and absorbed by our atmosphere, ensuring minimal impact on our planet's biosphere. While the explosion itself won't pose a direct threat to Earth, the cosmic light show will undoubtedly spark conversations, research, and possibly even concerns. Beyond the tangible and scientific, the explosion would have profound effects on human culture. The sky, observed and revered for millennia, would have changed. This alteration would lead to reflections on impermanence, the vast scales of cosmic time, and our place in the universe. Such cosmic wonders remind us of the ephemerality of existence and our eternal quest to comprehend the great beyond. Thanks for watching this episode of Nubila Lift. Don't miss the video you see on your screen, you won't believe it.